So you don't have to write the units within the, like along the axis. Okay, so we want to find out from the graph a few things. We want to find out total displacement. We want to find average velocity over the entire interval. And what else I want to find out? Well, let's find out acceleration also. Acceleration. So I'm going to label this A, B, C, D. So acceleration will be between A and B. Acceleration will be between B and C. Acceleration will be between C, C and D. Correct. Okay. Now, if you remember, we came up with the formulas for the displacement using areas, right? So all you do is just find the area under the entire, like this thing. Now, it doesn't matter how you do it. You can think of it as trapezoid, which is convenient here, or you can think of it like made of triangles and rectangles. It's up to you. So like triangle, triangle, and rectangle. That could be an option. So displacement is area under the, usually we say under the velocity versus time graph or curve, between the time axis and then that curve or line, whatever. So yes, let's find that displacement. So displacement. So you can break it down into pieces, right? So the first one will be how much from A to B?
It would be 10 times 10 over 2, so 15 for the triangle.
Yeah, so I'm gonna write 1/2, 10 times. Now again, I don't know if it's like really important. If you've done this before, you should know that units will like cancel like this. You get meters at the end. I think it's important. So this is A, B, and then we have, so this will be total, right? For the BC, it's the 20 by 10, right?
Yeah, 20 times 10.
So 10 will be meters per second times 20 seconds. Seconds cancel out.
200 meters.
Yeah, and then
10 meters per second times
10. 1/2. 10 by 10 again, right?
Yes.
Times 10 seconds again. So it's important to see that all the units come down to the same thing. So in this case, we get total displacement. 50 plus 50 plus 200, that's 300, right?
Yes.
300 meters. Now, I'm not putting plus sign here, but it's there, right? So you can think of it as actual displacement rather than distance, because we know the area is positive. Area could be negative because it has the meaning. Unlike area in math problems, which could be just a number, right? In this case, we have units attached to the area. So these units represent something. In this case, they represent positive displacement. If we had the graph below the time axis, we would have negative displacement, and we'll get there a little bit later. Okay, so just because I put the sign, don't think this is just a number. It has a plus in front of it. So I'm gonna actually put the plus here. In the future, that will be dropped, okay? But you should understand it's there. General thing that you have to understand is like graphs have areas, right? Area may represent as a certain physical quantity. In this case, displacement. In some cases, it could be velocity. In some cases, it could be energy, work, other things, right? So they have a physical meaning, okay? So, and then this is one of the tasks. When you solve the problem, you have to find out the meaning of the solution. This one means displacement. So let me write the displacement here. Okay, and let's just finish up the rest of this stuff. Average velocity. Question?
Yeah, so why exactly does finding the area of the trapezoid get
displacement? Because displacement is
Go ahead.
equal to velocity times time.
Mm-hmm.
So basically, if velocity times time is just the area of the graph.
Make sense, Ian? In middle school, you learn, what's it called? Rate formula, right?
Yeah.
Do you guys use R for the rate?
Yeah, we use R.
So R equals displacement over time, right? Something like this?
Yeah.
Yeah, something like that. Okay, so now we're not using R, we're using different symbol, and D is lowercase d, but essentially it's the same thing. Okay, so average velocity. Total displacement is known. We know total amount of time, so we can easily find that. What is it? 40, right? 40 seconds.
Yeah.
So that's about, what is it? 7.5.
Yeah.
Again, it's a velocity because we know there's a positive velocity. The object has moved forward. And let's find out accelerations now. Now this part is really easy because acceleration is a slope of v versus t graph. Let me box this thing. So this way will be there. Okay. All right. So let's do that. Alif, can you mute yourself? We hear a lot of noise.
Sorry.
Thank you. So let's do this. A from A to B. We need to find the slope, which is a rise over run, right?
Yeah.
So 10 meters per second. So this one, the first one, I'll do the like in a very formal way. Final velocity minus initial velocity. That's what is on top, right? Over the time interval delta t, which is 10 seconds. So now this becomes a go away. This becomes this. Look, a acceleration from A to B, 10 meters per second per 10 seconds. So it's 1 meter per second squared. So that's the unit of acceleration because you change the velocity by meters per second, right? Let's do the other two. So those two will be like done in a less formal way. B to C. Since it's a slope, we don't really have to really calculate it. We see the slope is 0, right? So I don't have to calculate that. We could calculate that, but I will prove the same thing. Just visually, you see it's like flat, so it's 0. And then C to D. So now initial velocity is 10 meters per second, but it's finally 0. So we're going to follow that final velocity minus initial velocity over same 10-second interval. Just put 10 seconds. Right, so now you see the minus popped up, so which means acceleration is negative 1 meter per second squared. And why is it negative? It was
Because it's decreasing.
Arshad, yeah, Arshad.
Sorry.
Go ahead.
It's because it's decreasing.
Because it's decreasing, it's slowing down, it's losing speed. Okay.
Are we gonna have problems where the velocity graph is like a curve or like
No.
not just like a line?
No. Those are calculus level problems, right? AP Physics C level problems. However, when we get to instantaneous velocity, we will see curves, but you will only have to find a specific like velocity of a specific point in time, or average velocity, which will be average slope. Okay, so we'll have a separate lecture on how to read the graphs, interpret the graphs. So there you may see curves, but you won't analyze it in detail, like how the curve is changing. When we get to, if we get to the, what's it called, harmonic oscillations, then we will analyze it a little bit. There will be a little bit of calculus, Got a little bit taste of calculus then. Okay, until then, no. Okay, I think we're done.